Kanga. Hello, hello. We are ready to start the last event of the day. We'd like to call you to come in for those who are interested to know exactly what is the benefit of using climate information for socioeconomic benefit. We call our colleague to take place, and we are inviting all the managers of the program, ICPAT, Agreement, ACMAT, to come in front as the panelists. Okay. I will call you later, really, to come to the podium. Yes. Ok, je pense que je peux lancer déjà les vidéos parce qu'il est déjà temps. 18h30. Tu veux attendre quelques minutes encore?
Je ne sais pas si on aura plus de monde.
Non, non. Je crois qu'on passe. Oui, on lance. Allez-y.
On va y aller après. Donc là je suis sur la clé, hein. Je ne suis pas sur ton...
Oui, oui.
Ça, hein, tu l'as pas copié. Hein.
Là, c'est sur la clé, oui.
Je te la laisse ou pas? Tu le veux, le
Non, non,
renard?
si.
Tu t'en fiches?
Tu laisses encore comme ça parce qu'on ne sait jamais.
Essentially, the ClimSA program seeks to assist us in developing our climate services. We've been doing this in the region probably close to a decade now. In fact, when we finally launched our GFCS program, Global Framework for Climate Services, this is back in 2013 in Trinidad. And we have, through a number of initiatives, been expanding our climate services, our climate information. But we've reached a stage now where, I think our activity across the region as an RCC, a regional climate center, the word is now out, the number of information products and support to our particularly socioeconomic, key socioeconomic sectors. And now it is to enhance these. We know that there are a number of things that we can provide or improve that would assist in decision making to reduce risk from climate-related hazards in the Caribbean. And ClimSA is there to help us enhance those products, help us to build new ones that we know that our clientele would be able to utilize to make those important decisions that, as I said, will reduce risk in their sectors.
We are welcoming you in this last event. For the logistic matter, I think there is a translation. If there is people who would like really to have facility in French or in English, they can ask for the headset for them to be provided. As our program for tonight, let me share it so that we know where are we going to. I will just introduce the high table and to give the objective of this site event. I will call Madame Pratt, who is the Assistant Secretary General for OACPS, to give his keynote remarks. And after her, we are going to get online speaker. David will start the flow. After David, Scott will come. And after Scott, we'll have the discussion. During the discussion, we'll call all the RCC manager to come in front as the panelists. When we finish the first round, we'll go for the second round of the event. We'll call Tanja, will come in, and the last one, I will be part of the speaker for the last session. And after the last round, we'll have also another discussion, and we give the floor to everyone we like to making inputs on the subjects so that we can have discussion and conclusions. By saying this, why are we here today? The OACPS, which is the Organization of African, Caribbean, and the Pacific State, through the program intra-ACP, Climate Services and the Related Application, ClimSA, together with partners from Karlsruhe Institute of Technology, in partnership with University of North Dakota and the Ventana system corporate, they've developed a tool to assess the benefit of climate information to socioeconomic sector. So today we are going to present a type of the output of that tool, how the tool can help us to raise the awareness of the decision makers in terms of providing resources to develop climate services and its application. This site event would like to promote policy dialogue, meetings to demonstrate to the decision makers the benefit of climate services for socio-economic growth. The tool you are going to see the outcome or the output is meant to assess the socio-economic benefit and to provide decision support and information to inform decision makers on the budget allocation to develop climate services. Today, it will be just to show you what could be the benefit of that tool for raising the awareness of the decision makers in terms of budget allocation. Today, I would like really to give the floor to my Assistant Secretary General for the OACPS to give the keynote. You can even give the, yeah.
Thank you very much, Dr. Farker, and I'd like to bid good evening and to thank you very much for joining us today. On behalf of the Secretary-General of the Organisation of African, Caribbean and Pacific States, His Excellency Georges Rebello Pinto Chicotti, I'm honoured to bid each of you a warm welcome to this side event. The aim of the intra-ACP Climate Services and Related Applications Programme, known as ClimSA, is to strengthen the capacity of decision makers at all levels to use climate services and applications in making better informed and contextualised policy and practice decisions, to build resilience and sustainability in and across the 6 regions of the OACPS and in its 79 member states. I'm pleased that the OACPS is co-hosting the side event with the Karlsruhe Institute of Technology of Germany, who are also working on climate services and its socio-economic benefits. Distinguished delegates, your presence reflects your commitment to participate in promoting climate action while seeking ways and means to strengthen collective commitment to demonstrate the use of climate information for sustainable development and resilience building. Indeed, the assessment of options, processes and enabling conditions for climate risk management are key considerations for climate resilient development. Climate services that provide reliable, relevant and usable climate information for the short and long term are increasingly being produced and used in climate risk management. Climate services already play a crucial role in determining strategies for adapting to the effects of climate change, and one should expect demands for these to increase in the future. But currently, its full acceptance and uptake is lagging due to the lack of data and information on its impacts on socio-economic development. Therefore, the intra-ACP ClimSA program intends to provide an overview of the types of decisions made by different stakeholders that might be informed by climate services, with a focus on the socio-economic benefits of providing information about climate impacts and adaptation in and across OACPS regions and countries. The implementation of ClimSA is truly a multi-partite effort. The overarching technical assistance to ClimSA is coordinated by the OACPS Secretariat, while the program is implemented by all 6 OACPS regions: Southern African Development Community, SADC, the Intergovernmental Agency for Development, IGAD, the Economic Community of West Africa, ECOWAS, the Indian Ocean Commission, IOC, the Secretariat of the Pacific Regional Environment Programme, SPREP, the Caribbean Meteorological Organization, CMO, and the African Union Commission. It also benefits from the World Meteorological Organization, WMO, and the EU Joint Research Centre, JRC, and the European Organisation for the Exploitation of Meteorological Satellites, EU METSAT. And these last 3 are key technical implementing partners to ClimSA. A key outcome of this side event is to showcase the first results of a socio-economic benefit tool that has recently been developed by ClimSA in partnership with Ventana Inc. and the University of North Dakota, which intends to enable measuring the socio-economic benefits of climate services. To date, it has trained more than 20 professionals from OACPS regions. The Secretariat of the OACPS, together with our already mentioned partners from Karlsruhe Institute of Technology, Ventana Systems Inc., and University of North Dakota, are collaborating to promote policy dialogues and discussions to demonstrate to decision makers the benefit of mainstreaming climate services information into development policy and practice decisions for socio-economic growth. Climate services have the potential to sustain the application of current and future climate information for government, industry, and individuals to make informed decisions. To address decision makers' needs, scientific data must be presented at the appropriate geographic scale and time scale to aid effective decisions and actions to be taken. Decision makers need information tailored to their particular needs that are communicated clearly, and that are accompanied by decision support tools that enable and allow the exploration of alternative pathways and flexible responses to new information as it becomes available. In closing, I sincerely hope that this side event lays down the groundwork on demonstrating the business case of the importance of climate services and applications in providing timely, quality, relevant climate information. Climate information needed for better informed socio-economic policy and practice decisions at national, at sector, and at other levels. For example, appropriate climate information that is needed by our smallholder farmers and artisanal fishers to enable them to make timely decisions to ensure their livelihoods and well-being are secured and protected. I trust it is compelling enough to ensure that there is a wider realisation of the importance of climate services and related applications as an imperative for informing policy and planning decisions at all levels and scales. So I thank you very much for your attention, and thank you, Derdane.
Thank you, ASG, for giving this key remark. Now we are going to give the floor to our first speaker, David Peterson, will share with us the background of this tool of assessing the benefit of using climate information to socio-economic sector. David, you have got the floor. He's online.
Can anyone adjust the phone? Can I be heard in the hall?
Yes.
Oh,
okay,
thank you.
Yes.
Thank you, Ms. Pratt. Thank you, Dr. Faka. Are slides being presented, or should I try to share my computer screen?
If you have challenge, we can still. Yeah, that is the one. We have the presentation with us. Maybe we can help you to.
Oui, oui, il faut le mettre.
I'm wondering if there's some way I can adjust,
C'est pour ça qu'on
I
a
can share my screen. I don't see a way to do that here.
Excuse me, David.
Yes,
You're going to use what are we showing here? You are just continue just presenting, and we are going to share with the audience your presentation here.
C'est nous qui lui mettons.
Yes. Your presentation is already there, so you just speak and we can continue. Sorry, there is not the voice, micro.
Je pense qu'il ne la voit pas.
Can you see the presentation? we apologize for the technical challenges. I think David is trying really to see. We are presenting your slide, and you can continue just speaking. There is not micro. Micro is, you are muted. There is no sound. Please, can you assist? You know, with the technology, sometimes it can assist, it can help you, but you also need to bear with math, to be a bit patient. We're going to sort it out and to continue our presentation. Yes, ma'am.
Hello.
David. Hello, David, do you hear me?
Please, can you
On n'entend pas. طب اكتب لي في الشات.
You need to give him the right to share the screen. He's in, but he can't share the screen until you allow him to.
That's what I was thinking. خليه بقى هو allow him David.
Make a presenter.
Does the Zoom meet the people in Zoom hear the translation? People in the Zoom meet
Hello?
hear the translation? Or does
Yes, we can hear you, but now you don't have in the system, the PS system doesn't really translate your voice. So that's what we are trying really to sort out. But it's still not activated.
Why is it not activated?
David, do you hear something? Do you hear me? We can't hear you.
Why? It should be automatic.
Can we hear Scott? Scott, can you hear me? Scott?
He's hearing you.
Yeah. Okay. Mais on l'entend pas.
Sorry for the challenge. I think we are going to shift to the physical presenter while we are continue sorting out for the on virtual participant. So we are going to ask Dr. Tanja from the KIT to come and give. We can get the virtual.
You understand what's the problem? Do you know what the problem is?
Yeah,
There is something with his laptop or any
Yeah,
technical
maybe.
problem with it?
we have problem with the microphone. We were here.
So hello, my name is Tanja Portele from KIT. Sorry, Mr. Facker? Yeah, because
Turn off.
computer. Here.
Which computer is I don't
Good. Thanks for the opportunity to be here at the ClimSA site event. As I said, I'm from KIT, and I also want to acknowledge my colleagues, Dr. Lorenz and Professor Dr. Kunstmann. And this evening, I will talk about the seamless predictions from weeks to months for proactive water management and decision making.
The problem is he cannot be able to share the screen from there.
Teams. Okay.
Yes, he has the right, but he cannot share.
Well, it's minus.
اوكي سو هي هاز ذا رايتس هير بس that doesn't show there.
Yes.
طيب احنا عاوزين دي تطلع على الشاشه.
It doesn't work here. Do you know?
Oh, I see.
Yeah, here it works, but not there.
It's okay, but it's working here.
No.
Oh, no, it doesn't.
Technical problems, sorry, this evening. Yes. Yeah.
It's okay now. Huh?
No, it's not.
Yeah, just follow this one.
Yeah, it's not working.
Oh,
Yeah.
so now it shifts.
Yes.
It can't move now.
Oh,
I don't know if you, the audio.
what did you do here? Ah, just erase
And
it.
delete something?
No, you inserted something.
Okay, okay. Okay. You just speak by following your slide here.
And
It's
they
unfortunate.
don't see.
Yeah, so I don't know how to deal it with.
Put again.
Yeah?
The HDMI put again. Connect it again and then. Oops.
Yeah, this is a problem. It's not sure.
So you are not. You should be digital cleric account here. You should use the digital cleric account for signing in. You can use the other laptop for.
Yeah, maybe use your own laptop. Because
Yes,
I don't have
you
it.
can use it and go. Through.
Oh, sorry. We are very, very sorry for this challenge. Sorry. Yeah. Yeah, that's one.
Dr. Tucker? This is David speaking. Can you hear me?
Yes, we can hear you now.
You might try, at the upper right screen, there's a button called Share. If you click it, it might review what you want. I'm not sure.
No, the second one. Yeah, that's it. Yes, we are changing the laptop. Maybe there is a problem with my Facebook laptop. I think the IT is there, taking to sort it out. Sorry for the inconvenience.
That works. I now see Dr. Portele's slides.
So, finally we can start. I think here at the COP27 I do not need to tell anybody that climate change is already acting now and that extreme events are occurring more frequent than in the past. But I want to start with the need for proactive water management, and this exactly comes from the more frequently occurring extreme events like droughts or floods or heat waves. Just recent examples from a drought were here in the Greater Horn of Africa that faced the 5th consecutive failed rainy season this year. An example of flooding at the same time was observed in South Sudan, where so many people were affected. So to achieve this proactive water management, we need to provide climate services to help for disaster preparedness to drought, heats, and floods. Only with climate services we can provide decision support. And for this, we really need to look at the right timescales. So for decision planning in agriculture, water resources, and energy, we need to consider the timescale from days to several months ahead or even seasons. And only if we consider these timescales and provide then the decision support, we can achieve socioeconomic value. At the needed timescales, so in the seasonal forecasting activities, WML already has a lot to show. So there are already 14 global centers that produce seasonal forecasts, for example, the ECMWF in Reading. And these products from these 14 global producing centers are already used in consensus-based regional products, and they are shown and presented at regional climate outlook forums, for example, the GACOF and the Greater Horn of Africa. So already a lot is done in the seasonal forecasting scene, but there is still research required because there are limitations of global raw forecasts, and we really need to apply those forecasts for decision making, and we also need those for impact models like hydrological models or agricultural models, so crop models. So the limitations are model biases and coarse resolution. Here show an example of the seasonal precipitation sum in seasonal forecasts and in reference data. We of course see the biases, but also the coarse resolution of the seasonal forecasts. So it is clear that this has to be corrected before we can really apply it for water resources management. Second, there are also model drifts. That means there are deviations from the mean reference climate the further we go away from the start time of the forecast. That means the forecast can drift to too dry or too hot weather conditions, or they can drift towards too wet or too cold climate. So really post-processing of those seasonal forecasts is crucial if such information should be used for regional water management or impact models. So it is not only the role of the research to provide those improved and refined seasonal forecasts, but it's also to bridge to application. So also only with close co-design and co-development with local stakeholders and end users, we can provide the decision support. And finally, to the transfer into practice. Here we also need to know that seasonal forecasts are ensemble forecasts, so all information that can be provided is only given with a certain probability. So we really need to jointly develop a system, which is here an example which we developed during the Savan project for the Blue Nile and Tekese Atbara basins, where we show the seasonal forecast in an understandable manner, tailored to the decision makers, and also, just understandable and to be used for water resources management. It is really nice to have such a prototype, but actually decision makers need to know, is it really worth doing a different action during, for example, a drought? And for this, we did a real case study at the Upper Atbara Dam complex in the Nile Basin in Sudan. So during it was the goal to see if an adapted water management during drought really brings economic benefit. So here we see the reservoir level that is lowered towards the rainy season to be able to capture all the peak flow coming. And we see that the most energy is produced during the rainy season. If you have then a drought coming, the peak flow does not come, or not in the same manner as during a normal season, and then we have less energy produced during this drought season. However, if we adapt our management here to not lower the reservoir level as much, we can actually save losses for the case here up to $60 million US. And others would say, yeah, what if the drought does not come, but we have not lowered the reservoir level? Then it will only mean that we have actually a cost of action of $6 million US. So we now have the prototype available with the improved and refined seasonal forecast. We showed that there is economic benefit of adapted reservoir management, but actually the research also needs to show how good are the seasonal forecasts. Here I do it in terms of the maximum potential economic value of seasonal drought forecasts, here for SPEI, so this means the Standardized Precipitation Evapotranspiration Index, for 1, 3, 4, and 6 months ahead. And the economic value then shows how much savings of an optimal early action can be achieved if we base our decisions on seasonal forecasts. And we see that seasonal forecast-based action for droughts can actually achieve economic savings up to 70% of those from optimal early action. And even for several months ahead, so for example, the 6-month drought ahead, savings of at least 30% are possible. So we really have economic benefit of when we use the seasonal forecast for decision making. So our activities at the KIT are, for now, the performance evaluation and operationalization of regionalized seasonal forecasts for semi-arid domains. This was done in the Saban project that ended last year. We are currently also involved in the CONFER project with seasonal hydrological forecast for the Greater Horn of Africa, with a focus on the co-design and stakeholder involvement also with ICPAC. And we also expand our work to West Africa and also for Germany. But as I told you, it's not only the seasonal forecasts that are decisive for climate services and decision making, it's also the forecasts from days and weeks ahead. So the sub-seasonal forecasts also need to be addressed. And that's what we do in the coming 2 projects that we have. One is globally, and the other is in the Blue Nile region. And there, we really want to go to a seamless prediction system from days to months ahead, and also produce cloud-ready regional forecasts, so that it can be used by the stakeholders and end users also at their systems. So finally, we have a lot of things ready. We want to share our results, and we want to discuss and disseminate here our work. We want to connect to more partners, so I'm really happy to discuss with you to finally then support the resilience and adaptation to and the mitigation of extreme events with forecasts from days to months ahead. Only when we build interdisciplinary and intersectoral bridges, so we can really improve the adaptation possibilities here. So all disciplines and sectors need to come towards research that we can finally implement our results and create real outcome. So just save the date, there will be another side event also with ClimSA next week in the African Union Pavilion with my colleagues Dr. Lorenz and Professor Dr. Kunstmann. And yeah, with the two articles here, research articles, I want to thank you for your attention.
Thank you, Tanja, for presenting this study on East Africa and also expecting to extend to West Africa. I would like maybe to get some question for clarification. If there is someone who would like really maybe to raise a question to clarify, maybe you did not get to well, before us to go to the panel discussion, where we are going to call all our RCC's manager to see the benefit of this tool, how it can help them to manage their business and also to make awareness to the decision makers for them to invest in climate action. But for now, I would like maybe to ask a question for clarification. Somewhere you did not get to well in the presentation so that our speaker can give more detail. If there is not, I will rush for the next speaker. After the next speaker, then we can open discussion with the panelists and to see exactly how should we build our capacity by using this tool to convince our decision makers to invest in climate services development. So now, I would like to call David, if possible, to share your screen and present your topic.
Okay, Dr. Faka, can you hear me now?
Perfect.
Okay, I'm going to share my screen. I hope this works. Can you see OACPS template country economic model?
Yes, we can go ahead. Thank you.
Okay, I'm going to, in the interest of time, I will go immediately to the first slide with content. So let me, okay, so under the direction of Dr. Faka and his colleagues, including Dr. Natalie, we've developed a country economic simulator for application to the OACPS countries. OACPS is the Organization of African, Caribbean, and Pacific States. Over 20 meteorologists from OACPS countries met with us in 13 workshops, and the same delegates also attended discussions and instruction classes at the University of North Dakota, all by remote. And during those workshops and classes, we together developed what I'm about to show you, which is a template model, which is a baseline starting point to make a specific model for any one of the OACPS countries. The model is, as you'll see in a moment, is based on input-output theory, in which we look at an economy as something that has things that it absorbs and things that it produces. And many of the things that are absorbed in the economy are also things that are produced within the economy. So, for example, the agriculture sector may not only produce crops, but also, for example, wood. And that wood may be used for construction of the fixed capital in other sectors of the same country. So it's an old and well-established economic procedure to estimate the input and output activity in individual countries. And these are published in the form of input-output tables that give the output of each sector of an economy and the inputs used by each sector of the economy. And the inputs include imports from outside the country, and the production of the different sectors is sometimes shared with the rest of the world as exports. So it's a good way of taking high-level look at an economy from a perspective of the internal constraints to the economy and also its interaction with the rest of the world. And so the model I'm about to show you can be calibrated to match the specific data for a particular country. And it can also be used, most importantly, to look at the future of the country and to estimate the effects of global warming on the economy of that country, and to not only quantify damage, but to look for the benefits of adaptive measures and technologies. So the model has many sectors in it, and we've deliberately designed the template model so that the level of detail in the model can be adjusted. So input-output tables at one extreme deal with typically only three categories of activity, namely industry, agriculture, and services. But input-output tables are also available which divide the economy into over 100 different sectors. And we've made the OACPS template model such that it can be readily adjusted from 3 sectors up to as many as 20, and with some modification could go even more detailed. In the workshops where we developed the model, we tended to stay with an 8x8 view, an 8-sector view of the economy. And but even though there are 8 sectors in the simulation, they project into other kinds of things. So these items, this is actually a page from the model itself, and in the live model, if one clicks on one of these things, it takes you to the part of the model that details the aspects of that part of the economy. So here's a simulation of the model. We've deliberately designed this baseline simulation so that the future GDP of the country is constant. So we've adjusted the fertility assumptions in the country and immigration in and out of the country to give an easy to remember baseline of constant activity just for the purposes of these slides. And then we can simulate this baseline economy, which is a reference of what we think would have happened if there were no global warming damage to the economy. Now, this simulation, or this graph, starts in 2020, and we all know that there's already been damage to a typical country before this graph. So we'll see in future graphs that the baseline actually has some damage factored into it already, and that can be remedied. So it is possible to get simulations that go above the baseline. But the difference between these two graphs is the year by year, and if you take the area between the blue and the red curves, that's the cumulative damage over future decades of global warming to the economy of this abstract example country. And as we said before, this model can be adapted and calibrated to represent a specific actual country, in which case these curves would be different, but would also be more meaningful. So here's an example of what happens if improved climate information systems of the kind that Dr. Portele was just talking about could be implemented starting in 2030. And you'll notice that that has some remedial effect on damage already incurred, and so that the GDP of the country rises above the normal damage. And so the area between these two curves now is the benefit quantified in monetary terms, our dollar sign here means real dollars, meaning without inflation. So this is a reference currency measure in terms of money of how much benefit could be obtained from an adaptive, in this case, climate information system. Then there are other kinds of adaptation. So if this is, many of the OACPS countries have coastlines and some of them are low-lying islands. And so the possibility of seawater intrusion onto the land and into the aquifers is a serious threat for these economies. This shows a prototypical consequence of installing in 2030 a seawall of a specified number of meters of height. And that in itself can provide grounds for improvement even above the baseline. And it can certainly prevent further damage until or unless the rise of sea level from global warming starts to reach the top of the seawall. So this, again, this area between these two curves represents, in money, the benefit of an adaptive measure, in this case, an infrastructure adaptation. So that's the overview, very brief overview of the construction of the model. The reason that we did it was we had very valuable time from the delegates from the OACPS countries. I believe almost all of them were professional meteorologists. So they're very knowledgeable about weather and about effects of climate. And we wanted to make sure that in constructing or in using the model, that they would not only know what's in the model, but how it was constructed. So we actually started with a blank screen at the beginning of the first workshop, and together with the delegates constructed the model over the course of these several meetings. So that way the delegates not only can understand and use the model, but they have enough depth of knowledge of the process by which the model was built, so that they have independent judgment on what they would like to change and what was easy and what was difficult and that sort of thing. So it's been a great pleasure to work with Dr. Falca and the delegates he assembled. And I think we have a good start here for enabling the construction of calibrated and tested models for individual countries that can be used to look at the costs and benefits of global warming and the benefits of specific adaptive investments and technologies. So I'd like to now turn over the floor to my colleague, Dr. Scott, who is going to explain how the instruction was organized at the University of North Dakota. Scott, can you, are you able to speak?
I am able to speak. And David, we're going to continue to use your slides?
Yes, I'm now positioned on the first UMD slide.
Very good. Well, thank you very much, David and Dr. Falca, for the opportunity. At the University of North Dakota, the goal of our involvement was to help the OACPS folks build capacity to apply the Ventana National Template Model to a specific country. So we had three specific objectives. One, we wanted to teach the fundamentals of the system dynamics modeling technology. We wanted, very importantly, to train the operations of the Ventana Venson DSS software, which is what the template model is implemented in. And the third objective was to train the logic and operation of two important Ventana models, the main national template model and an associated country-specific data model and the associated data tools. Next slide, please. So the target of this capacity building training was to allow the delegates to earn a graduate level certificate from the University of North Dakota, consisting of 3 courses. System Dynamics 1, that was designed to teach and practice the fundamentals of system dynamics. 2, System Dynamics 2, which is where they practice a country application. And the 3rd course, titled Managing Resources and Policy, where the delegates would use the model for scenario analysis and also practice and learn about techniques for engaging with decision makers and policy makers. Next slide, please. So the approach that we used over a duration of 5 months, first of all, it should be noted that this is what we did, and we might do something slightly different in the future, but we had a compressed schedule that we adhered to in order to accommodate the OACPS leadership. And the mode of instruction was online. There was no travel involved. And the delegates attended 13 periodic Ventana modeling workshops. And as David mentioned, the goal was to provide them an opportunity to participate in the model development activities. In between the workshops, there were 2 weekly class sessions lasting about at least an hour and a half, sometimes 3 hours. So we were flexible in that regard. And finally, between classes and between workshops, we afforded the delegates an opportunity to participate in additional online learning sessions as required. So that is a brief summary of the instructional program by University of North Dakota. Thank you very much.
Thank you, David. Thank you, Scott, for giving us the overview of the tool. I would like now to bring you down. Sometimes you did not get exactly what did we do during these courses in terms of the tool was developed. You saw in David's presentation the benefit of using the climate information to socioeconomic impact our sector. You saw also if there is the sea level rising, how country can benefit to protect the economy and get benefit. That can seem like a black box. How did they come out with those green and the black line? To draw that line, there is a big mechanic of system dynamic beyond. It's not like just you get your pencil and you draw a line to show people that this is the benefit. So my intervention is now to bring you down and to show step by step what was done for you to get exactly the insight of the model, and to encourage others who did not attend to come in and to benefit in these courses. Let me just share my screen. Yeah, so I will go a bit more in detail, not really giving all the subject on the methodology, but the big step we follow to build this model. First of all, the OACPS socioeconomic benefits tool is based on giving the guideline actionable climate-informed decision-making to mainstream climate to policy and strategy. We are intending also to increase climate services development and application to the sectors. We are also intending to lead to the investment decision to climate action. What is the methodology we use? As you know that today there is no more effort to show people that climate is changing. And this change has got a big impact in terms of the economic losses, in terms of the physical damages. That is really not for us to demonstrate it. It's already well proved. Our methodology is based, as David and Scott has pointed out, based on the system dynamic methodology. I'm not going to come back again what already David explained, the dynamic of the input and output methodology. But let me give you an overview. To do that dynamic socio-economic production system, you have a kind of this drawing. Of course, I can't see it there. I don't know, my screen is not shared. Because I'm talking myself here. It was better for you to see also how things look like for you to get the insight of the model. Anyway, still it's a bit challenging.
Dr. Faka, are you able to hear me?
Yes.
If I had the same trouble that you had just now, when you share your screen, it shares the pictures of the remote participants. But once you now switch your computer to a different application that has the figure you want.
Yes.
Using Alt-Tab, maybe?
Okay, because we are really bad with time, let me just explain. So the first thing was just to describe what is the production sector, which is build the economy, and how those production sector are linked to the climate factor or the climate information. You recall and you remind yourself that agriculture sector is based on the climate information. When there is a drought, as Tanja has shown in the first presentation, when the level of water is decreasing, the production of the energy will be also affected. That also will affect in terms of the income for the country. When we are having a kind of drought for the agriculture side, it will also decrease the level of the yield. That is showing the straightaway link between climate and socio-economic sector production. So we put together those socio-economic sector for the global gross domestic products, how climate can affect those sectors. If we don't do anything, what could be the impact? That way, I was trying to show that agriculture and the fishing sector are linked to the climate factor. Water sector are linked to the climate sector. Energy sector are linked to the climate parameters. So the particularity of the OACPS model, we took in account, as showed by David, the effect of the climate information system. When we are using climate information system, what is the benefit? As he showed. The second particularity of this model is to get in touch or also to incorporate the effect of informal economy. You know, sometimes in our countries, all the factors are not well recorded in the main system of the national system. The informal economy is more predominant in our country. How the model can factor in the informal economy, so that if there is really a crisis, how population can be affected. The third impact or the third aspect of the OACPS model is also to show the impact of the social conflict. If there is a conflict in your country, in West Africa, how that conflict can affect the economy. So this model can inform decision makers that by having a conflict in the country, it's having also an impact on the economy. And how can we predict or prevent by knowing in this modeling the impact of the conflict or the social conflict or the economy? And the last point of this particularity of this model is to explain also the impact of the fertilizer in the key agriculture sector. You recall the president of African Union went to see his colleague from the Russia and Ukraine if they can release fertilizer, because our agriculture depends also on that factor. So putting all together, the economy production system and the climate system together, we are coming out with those graphs of the gray line and the red line to show that applying climate information is protecting our economy and increasing productivity, and also implying also to have a good gross domestic product at the national economy. So we are expecting that this tool can help the RCCs to convince the Minister of Finance, showing them that if you don't invest in climate services, look the impact on the national economy. If we invest in the climate sectors, what could be the benefits? So the first version of this model is to target ministerial level. We expect with the blessing of our ASG during the summit, if we can have in a site event when the ministers are coming to show them the impact of this model, that not paying attention to the climate action, what could be the impact on their economy. It could raise awareness for them to pay attention how much they are allocated to the climate action or climate activity. By saying this, I thank you for your patience. Now we have at least 15 minutes. We can make a debate. Do you think that this kind of tool can help RCC to inform decision makers in their country for them to pay attention on their activity? The KIT have shown a study they did in East Africa, where impact is part of the stakeholders. They show that during the drought conditions, there is a loss. What can we do with the focus to buffer that loss and prevent our economy to be sustainable during the crisis? So I would like first to give the floor to our manager of the RCCs to give us their impression. What do you think in terms of your management? How this tool can help you to manage your activity and also to inform the decision makers in terms of paying attention on your activity? We have agreements, we have ICPAT, we have ACMAT. We like first to hear your voice before to turn the micro to all the audience. Yes, the micro is there. Anyone can take the floor. You introduce yourself and you get the floor.
Okay, thank you. I'm Seydou Traoré. I am the manager of West Africa ClimSA program from the Agreement Regional Center. Yes, so regarding this socio-economic benefit tool being developed in the framework of ClimSA, I must say that we are looking forward actually to have this model and to implement it. Right now we have selected 2 young scientists from our pilot country, Burkina Faso, and from what I understand, they are following this very closely and very successfully. And actually, in Burkina Faso, we selected 3 rural communities where we implement our activities, giving climate information to farmers, and also involving many of our stakeholders. And during our interaction with those, we really feel that they appreciate a lot what we are giving to them. It helps them a lot. And also in our interaction with other stakeholders such as decision makers, of course, we just relay what our partners on the ground are saying, but these are declarative. So this socioeconomic tool will help us actually put figures on whatever we are willing to tell the story, to tell our stories. This tool will help us really get concrete figures, and so we are looking forward to having this and to convince more in terms of real figures, various decision makers and partners. That's what I can say. Thank you.
Thank you, Agreement. We can hear the voice from ICPAC, East Africa.
Thank you very much. My name is Zakar Adoro. I'm the coordinator of ClimSA in Igan region. What is my take on this? When we conceptualize the project, we understand that we needed to influence the decision makers. And we thought what would really be the information we will use in order to influence the decision makers. So we thought of the socioeconomic benefits of climate services, and we planned to do assessment of the socioeconomic impacts of climate services. Then this opportunity came, and we nominated experts from the focus countries to participate in the training. At the same time, we currently have a consultant to start the work on socioeconomic benefits. So our intention is this consultant, when goes to the country, will need link with those experts being trained to do the work. So we think there will be the link in the countries so that you can be able to improve on what the socioeconomic expert is going to do. Once we have the results, we also planned high-level meetings. We are having one towards the end of this month, 29th and 30th of November. But this is introduction because we don't have already the results. But we intend, when we have the second one next year, we'll have already the results of this consultancy so that we can be able to influence our decision makers so that the mainstreaming of climate services in policies, development plans, and programming. Thank you very much.
Thank you, ICPAC. We heard that we need evidence to convince our decision makers, and this tool can help us to get out those evidence to showcases. Thank you. We can hear also from ACMAT.
Good. Okay, I'm Andre Kamga from ACMAT. So before responding, I wanted first of all to an answer to this question. Is the tool being operationalized or it is under development? Is it under development or it is something we need to operationalize at the current stage?
Yeah, the tool is already developed. What is missing now, the validation with the ground data.
Okay.
We have set up the method, everything is there. Now you need to collect the physical data on ground so that you can get the result as ICPAT is already doing.
Okay, so there we are on the same page. So the state of activities now involve collecting ground data and then validating the tool. I'm asking this before this year, before the floods in Nigeria. We had a product with OSHA indicating the percentage of population in different districts in Nigeria who may be affected by floods. But the minister said, my concern is that to go to my village now, I have to consider about 100 kilometers of travel in addition to what I used to, because the main route is flooded. And it is a key issue. What will go in the model should come from assessments at the local level, interacting with people to understand what are the socioeconomic indicators of interest to a given area. And I think in addition to just validating what is there now that we can do, it may not cost a lot for us to take a specific case, probably in a pilot country, and interact with the stakeholders to actually identify the real indicators and do the modeling part accordingly. So on our side, taking this, actually it was this year that we face really this challenge and see why socioeconomic benefits or assessment of losses and damage to link with what we are discussing here is very important in the process. And we need to actually validate, identify tools, validate it, and consider using them. Based on our experience with trying to understand nature, we consider it's important to use many tools, if available, to sample uncertainty in the estimations we make and give robust options to the policymakers. So this initiative is very much in line with what we think and would like to do. And it's, I think this is a step forward in this process. Let's continue thinking about how we structure the dialogue and work together, because I link this to the presentation by KRT, right? Yeah. So we should put all those tools together, knowing that at the end of the day, if we are to talk to policymakers, we bring robust information with a good explanation of uncertainties related to the tools that we have. Thank you.
Thank you, Ahmad. Of course, because you did not see my slide, how did we model the climate information system in the model? We need to know, for example, the fraction of infrastructure vulnerability to the climate change. That fraction of infrastructure vulnerability, you need to bring it for your own study. Maybe the fraction for vulnerability of infrastructure in Niger will not be the same in Burkina Faso. So those are the kind of information we need to collect on ground to see exactly when you are doing your modeling, which fraction, what is the percentage are you going to put in to show the impact of the climate information system to the economy. You need to know also the effect of the agriculture productivity with climate. When there is a drought, what is the rate of failure of the crop? That rate could not be the same if you are making assessment in Pacific, in Caribbean. So those are the particularity will make real the validation according to the reality of the ground. Sorry. So we are going to collaborate to see how we can advise collecting the ground data which can inform the model to give you a realistic figure at the end of the modeling. Thank you. Yes, 2 minutes. Someone in the floor would like really to raise? Yes, can we start with him?
Okay, thank you. My name is Diaso Olorik Jacques. I'm from the National Med Service of Burkina Faso. I've been deployed by the Norwegian capacity to support the National Met. And I'm also the focal point of ClimSA for Burkina as a pilot country. So allow me to first of all thank all the presenters. I followed the presentation with great interest and also found that yes, it's possible to bridge the gap between research and application, which we lack in our countries actually. So I have both questions and also comments. So I'll start with the comments, then I'll end up with the question. I think this tool, first of all, that you present is what we as national countries are actually looking for, because it's become a bit difficult for us to convince our governments to actually pay more attention to climate centers and capacitate them to be able to deliver climate services. So if we have such a tool that is actually working, that allow us to actually show the benefit of climate services to the socio-economic activities within the country, we believe that we can convince our parliament, but also our government to actually support more our services. Having said that, my question to Tanja, right, is related to actually the issue of data, because what you presented, I can perceive that there is, it's very sensitive to actually quality of data that one can use. So, but as we know in our country here, we have big issues when it comes to network and also quality of the data that we collect. What do you do to actually overcome this? Maybe I put all the questions together and then each of you can share. Then to David, I want to understand more about the model. To me, I see it as something that I could have actually used to even see in the next 50 to 100 years to come, what could be the benefit of actually climate information again in the next 100 or 50 years to come? Is it something that is possible with this model? Or can I also come back 10 years back, like a kind of endcast, to see what could have been the benefit of actually using the climate information if I were to use it in that period actually to be able to reduce the effects on the economy? Thank you.
So thank you for the question. I start with the data scarcity. We're actually working in quite data scarce regions. So the first project that we had was in the Savam project, and it was in semi-arid regions. It was not only in Sudan and Ethiopia, it was also in Iran, in northeast Brazil, and then Ecuador, Peru. And actually, in all these countries, we had problems to really get the reference data that we need. And what we actually did is we used the reanalysis data from ECMWF, so the ERA 5 data, to correct the seasonal forecasts. So we actually use these reanalysis data as if they were real observations, because we do not have any other data that is available in these countries. And we also need not only the data for precipitation, we also need it at the same time for temperature, for maximum, minimum, mean temperature. And also for further applications, we need the relative humidity and so on. And this is can also not be provided in your countries. So we use the best that is available, and that's what we use the reanalysis data. So I hope this answers the first question.
Yes, they are letting me know that only 2 minutes left before to conclude. Okay, maybe you can raise the question, we can even answer in the corridor, but let us get it, because the room...
The second question? Or?
To David, that I'm saying, we can get first the question, because we are having the second site event on 16. What we are receiving as a question, we can address it during that, the second site event in Africa stand. Yes.
Thank you for presenter. But for me, it's not really a question, but it's an observation. So what you are trying to do for using the model is to show the decision makers what is the implication of using climate information. But it's also good for end users who are using our product to show them what is the implication of what they are using. It's in the same order. We did a work in around 8 municipalities in southwestern Niger, where we want to do the perspective assessment of socioeconomic benefit to end users. And for this perspective assessment, so it is shown that using the climate information, this community are benefit for about 24,000 francs CFA per hectares. And also those information allow them to reduce many types of risk, even going from for transhumance or coming from the exodus. They are using those information to monitor all those aspects. So there's many, it's not only for decision maker, but even those for who are giving information, they need to know how this information can help them. And the second aspect is about this the seasonal forecast they are saying about the river flow. We know in agreement we are using to date since I think 1988, and for us it's difficult to make the river flow forecast over the whole basin. We are using to do it over only a station, some few stations in the river basin. So maybe it's a place to share your experience on how you are making this forecast over the whole basin. Thank you.
Yeah, that is a good one, but we'll address that one during the 16 site event in Africa Pavilion. Don't miss that one. We can address all the outstanding issue and we can go more in detail. I think so we will learn for this challenge. Next time we're not going to face the same challenge of the technology. Thank you for coming. Thank you for your attention. We hope that we are building something together to make climate action to become a priority in our daily decision. Thank you.